Hi, my name is Nick Spear, and this is Dexter, the Intelligent Desktop Interface. The problem that we are trying to solve is that interactions with the PC are limited to the keyboard and mouse. You may have experienced this whenever you're away from your computer but need to interact with it. We want to make a system that enables users to quickly and easily interact with their computer while they are away from their keyboard and mouse. Our goal is to expand human-computer interaction with AI. By accessing peripheral devices such as the camera and microphone, commonly available on many computers, we are able to leverage modern machine learning models to create a system that allows the user to interact with their computer through voice commands and hand gestures. Our approach to this solution is threefold. Firstly, we need a voice assistant that allows users to communicate with their computer through their voice. Secondly, we could use computer vision to enable our program to see the users and allow them to control their computer with different hand gestures. And to tie it all together, we need a user interface that allows users to easily control our program and visualize different information on their computer. What makes Dexter different is that it's a programmable AI platform that allows users to implement custom voice commands and gesture controls to allow you to do anything you need in your workflow. You can start a conversation with the assistant by simply saying, "Hey Dexter," followed by whatever question you'd like to ask. Hey Dexter, why is the sky blue? Our machine learning models transcribe the user's voice, interpret their intent, and fulfill their question using synthetic voice generation.
Because of the atmosphere.
Combining these technologies together enable us to create a truly conversational user experience. One development we had in the project that we did not anticipate was the need for a cloud-based service to answer a variety of questions. We created a server that hosts our language model and enables us to ask it any question through the web. Depending on the question being asked, we route it to a variety of API services, including Wolfram Alpha for math questions, OpenAI's GPT-3 for conversation and open-ended questions, and Wikipedia for definitions and knowledge-based questions. By having Dexter in the cloud, we are able to answer a broader range of questions and expand our functionality over time.
Hi, I'm George and I was responsible for gesture control. The idea behind gesture control is that the user is able to control the operating system and other functionality such as macros and scripts through gestures. We do this by taking input from the camera and using artificial intelligence to determine the gesture. Depending on what gesture they perform, we execute a certain action. Here is a high-level overview of the gesture pipeline. First, we have a loop which grabs frames from the camera. We then pass these frames to an artificial intelligence model which gives us the coordinates on the hands relative to the frame itself. We pre-process the coordinates by normalizing it and passing the data to another artificial intelligence to detect the gesture. We check if the gesture is mapped to any function using pandas, and if it is, then we execute the desired function using PyAutoGUI. After we have the data, we feed the data into a feed-forward neural network model. It is comprised of a linear layer followed by a ReLU, and then another linear layer followed by a softmax, which is used for multi-class classification because we are trying to detect what gesture the user is performing. With gesture control, users will be able to control the mouse, keyboard, and operating system. They will also be able to control media playback and be able to customize actions to meet their specific needs.
Hi, my name is Eris Fitzgerald, and my main role within this group was with the front-end development, specifically designing and implementing the user interfaces within the Dexter application. The core look and feel of Dexter was heavily inspired by Iron Man's trusted assistant JARVIS. We looked carefully at design elements from the film that made JARVIS stand out, specifically things like color scheme, button layout, fonts, and especially the audio visualizer, which really brought the AI to life. We incorporated a lot of these traits into the dashboard while carefully adding things unique to Dexter, giving the users an innovative but familiar experience. When the user launches the application for the first time, we will walk them through an initial setup. This allows them to enable or disable any features they may or may not want. Additionally, we use this as an opportunity to show users how to use voice commands and gesture controls. Once the user is done with the setup, we navigate them to the dashboard and they are ready to get started. The purpose of the dashboard is to enable users to configure program features, start and stop the voice assistant and gesture controls, and to also create an interactive experience with PC monitoring and audio visualization. Our settings menu allows users to control many different aspects of the program, including device configuration, personal preferences, and custom voice commands and gesture controls.
Hello, my name is Cameron, and I was responsible for the dashboard and integrating the front end and the back end. Our application consists of two main programs. We have our dashboard program, which runs an Electron Node.js server, as well as our core Python program as a fast API server. We were able to communicate between the two servers using HTTP requests and JSON. By using a familiar web-based stack, we're able to leverage our existing knowledge and build the application rather quickly. We were able to compile the program into an executable and enable anyone on a Windows PC to download and install our program. For project management, we use Notion to track task progress and set deadlines, Discord to hold weekly meetings as a group, and a status checkup later in the week. We also had many one-on-one sessions for working on our specific part, and we use GitHub for source control. We learned to plan ahead and work ahead, expect problems and technical challenges, set realistic deadlines and expect delays, and stay on track for project requirements.
Hi, I'm Carlos, and I'm responsible for testing and integration. For the testing of our program, the main focus is to ensure accuracy in the performance of our models. After each major update to our code, we evaluate Dexter with several test cases. To assess the user experience, we tested a variety of common interactions and found out whether or not they were handled correctly. During testing, we noted any bugs and assigned tasks to the relevant developers so it could be resolved as soon as possible. Our first prototype of the voice assistant had an average response time of 12 seconds. We focused our efforts on reducing that response time, so eventually we were able to reduce it to an average of 6.6 seconds. With each model in our pipeline, there is a trade-off between speed and accuracy, so it's necessary for us to find a balance.
What motivated us throughout this project is that we were trying to find the current boundary of technology and maybe push it a little bit forward. We sought out to build something truly useful, something we can use every day. We learned a lot, we worked really hard, and we look forward to see where this project might take us in the future. Thank you.